Hello everyone, my name is Tej and today we will be looking at the insertion sort algorithm, that is another sorting technique. So to learn about this algorithm, we can basically imagine a deck of cards. So here I have a deck of cards that is you can imagine as an unsorted array 5, 4, 1, 3, 2. So imagine this page as the unsorted part and this page as the sorted part. Currently nothing is sorted. So first of all, if anyone is sorting their part of the cards, they would want to sort it in the ascending order. So we will be doing the same here. So first, coming the first element, we take the first element and place it in the sorted part. So now 5 is alone is sorted and this is the unsorted part. So an element that is alone is considered sorted. So 5 is sorted right now. So now we take the next element, that is 4, and check with 5. Is 4 less than 5? Then place it in its right position, in its correct position. So now 4 comes to the left side of 5. Now comes the next element, that is 1. 4 will be compared with 5. 1 will be compared with 5, then 1 will again be compared with 4 and will come in the correct position. So this part is right now the sorted part and this is the unsorted part. 3 and 2 remain here. So the next element that comes is 3. So 3 will be checked with 5, then with 4, and it will be observed that it lies between 1 and 4. Similarly, now this is the sorted part and this is the unsorted part. Only 2 remains here. Anyone can assume now that it will come here. So now this becomes the sorted part. For the pseudocode of this sorting algorithm, we will first initialize the array as 5, 4, 1, 3, 2, and n is the length of the array. Now we will start a for loop that will go from I equals to 0 till n minus 1 and not to the complete array. I'll tell you in a few seconds why, till only this point. So we will then initialize a variable current, that will be short for cur, is equals to I. That is the current iteration, and this is only the index, not the element at that index. So index only, and we will also store the next element that comes in the next iteration. That would be array I plus 1. This will store the element value, not the index. So here for the first iteration, I would be equal, for the first iteration I'm saying, I would be equal to 0 and next would be equal to 4. As you can see, the element I plus 1, that is element 1, is 4. So after that we will start a while loop inside it, and while the current element, the current index, that is greater than or equal to 0, because in this algorithm at some point it also becomes minus 1 or even minus 2. So this is the first condition, and the second condition should be that the array element at the cur index is greater than next. So if array element at cur is 5 and next is 4, so this condition satisfies as 5 is greater than 4. So we will do this array element current plus 1 equal to array cur. So what we have done here is that for the first iteration, cur was 0, so cur plus 1 would be 1, so array element 1 is 4. So in that position we have inserted or copied the value of array cur, that is 5. So at this point the array will be 5, 5, 1, 3, 2. We have saved the value 4 in here in the next variable. So the value is 4, the value of 4 is safe, it hasn't disappeared anywhere. After that we will also decrement the cur variable. After closing the while loop, then here comes the insertion part, the main part from which the algorithm gets its name, the insertion part, and here we will insert the value that we had saved in here, the next part. So array element cur plus 1. So as you can see here, first of all, as cur was I and for the first iteration and I was 0, so cur was 0 basically, and after this cur has become minus 1, so the loop has stopped because it has become minus 1. So at this point cur is minus 1, so here minus 1 plus 1 equals to 0. So we are indexing the value, we are putting the value at array element 0 equals to next. So minus 1 plus 1 equals to 0. So array element 0 equals to next. That is 4. So we have set the array element 0 as 4. And now after the first iteration, the new array would be 4, 5, 1, 3, 2. So 4 and 5, this is the sorted part now, and this is the unsorted part. So similarly, the loop will keep on going, and the array in the end would finally be sorted. In the end, we can just print the array. So as you can see, the for loop has a while loop inside it. So it takes a total of O(n) square time complexity. So now I will show you the code for this insertion sort algorithm. I have initialized the array as 5, 4, 1, 3, 2 here, and n is the length of the array, that is 5. So we will now start the for loop from I equals to 0 till I less than n minus 1, I plus plus, and initialize the variable cur equals to I. So cur will be set to I as only the index and not the element in the array. So here in the first iteration, it would be I equals to 0. So, and we will also initialize the next variable, that is array I plus 1. So for the first iteration, I would store 0 and the next variable would store the value 4 in the array. Now we will start the while loop that will have two conditions, that is current index should be greater than or equal to 0 and array element that is in the current index should be greater than next. Only then will the for loop run. So in this inside this for loop, we will set or we will copy the array cur plus 1 a place with array cur. And after that, we will decrement the value of the cur variable. So here you can see that after the first iteration, at this particular point, at this particular line, the array would look like 5, 5, 1, 3, 2, and the value 4 would be stored in the next variable. As you can see for the first iteration, array 0 plus 1, that is array element 1 is 4. So now the most important part of the array, that is the insertion part, would come here like this, array cur plus 1. Because at this point, as we have decremented the value, here it is now, after the first iteration, it is minus 1. So here minus 1 plus 1 would be 0. So array element 0 we are setting as 4 here. So now we can just print the array equals to 0, I less than 10, I plus plus, array. Yeah. So also you should make sure to run the loop only till n minus 1, because imagine if the loop was still only till n, it would have gone to the complete till the end of the array till this 2. So it would not have been able to check for the next variable, because if the last element is 2, then what would the next element be? Because I plus 1 would be nothing, because that is the last variable. So the for loop should only go till this 3, and the next variable will check for this 2 now. So now if I run the code, you can see that the sorted array has now been printed here, 1, 2, 3, 4, 5. So this was the code for the insertion sort algorithm, which completes the sorting in O(n) square time complexity. So thank you so much for watching.